Material science is an interdisciplinary subject. You will take elements of physics, chemistry, and earth sciences and bring this together in order to understand a whole range of different types of materials and material systems. The underlying premise of material science is to understand the arrangement of atoms within a solid and how this gives rise to useful and interesting materials properties. In terms of the material science course we offer in Cambridge, in the first year, you will take in series 7 different courses. These will start at the fundamental level of understanding the atomic structure of materials, leading all the way on the 7th course to materials under extreme conditions. I'll say a few words about the underlying contents of each of those courses in the next slides. With each lecture course, there is a practical which takes place over 1 afternoon per week in term, so 8 practicals per term in Michaelmas and Lent, and 1 practical in the summer term. The course starts by understanding the underlying structure of materials in terms of the atomic arrangement. This is a fairly brief course. It consists of 6 lectures and 3 supervisions and 3 practicals. And at the beginning, you will learn about the different types of unit cells that exist in the solid state. Moving quickly to course B, you will apply the understanding in course A to actually relate those atomic structures to the electronic, magnetic, and chemical properties of a whole range of different materials, with a particular focus on materials which have potential applications in different types of devices. The example I'm showing on the slide is barium titanate, which has a perovskite type unit cell in which under pressure the titanium 4+ ion moves in a unique direction, which induces an electric field. As you can see on the picture on the right, that creates a spark. That is the basis for an entirely new type of memory called ferroelectric memory, which is the basis of many modern types of computing processor systems. You'll also learn about magnetic materials. On the bottom left, you can see a magnetic force microscope image showing the domain structure of iron on a 5 micron by 5 micron MFM or magnetic force microscope scanning image. In course C, you will return to elements of course A and apply X-ray diffraction, scanning and tunneling and transmission microscopy techniques to understand the underlying crystal structure and how you can measure very precisely the atomic constants of a material, for example, the unit cell lengths. In course D, you will take forward the understanding of the atomic structure to relate it to the macroscopic structural and mechanical properties of a material. You'll learn about phase diagrams, for example, about what a material looks like under an electron microscope and how you can take these different material properties and tune them, for example, by adding dopants, by putting the material under strain in operation. To give you an example, how do you design a steel to take the weight of an aircraft as it's landing on the runway? In course E, you will look more carefully at the mechanical behavior of materials, particularly in the solid state. On the left is an example of a piece of material under tensile loading. On the right, an example of a composite material, in this case, an aircraft wing, bending. How much bending moment could a composite material sustain without failure? In course F, we're going to look at the natural world and see how the natural world has developed a whole different range of exciting materials which we can learn from and create engineered materials from, giving you the example here of spider silk, which has extraordinary elastic properties, and wood, how you can develop wood, or the idea of a composite structure, into incredibly strong and tough materials, taking the example of an aircraft wing. In the final course, G, we look at the behavior of different materials under very extreme conditions. The example I'm showing here is a spacecraft on re-entry showing the distribution of heat across the fuselage of that spacecraft. So you need to be able to develop materials that can operate, in this case, under very extreme temperatures without, for example, bending or extending, which could result in complete failure. So what's required in order to access the material science course? Well, at base level and A level in mathematics, chemistry or physics are ideal, but not mandatory. All other material will be taught to you through the lectures and supervisions. For any further information, please do not hesitate to contact me. My email is on this slide. And of course, you can look at the course content on the Department of Material Science website.